In the last module, we looked at some basic sampling procedures and their limitations. In this module, we focus on two advanced sampling procedures, stratified sampling and cluster sampling, that can overcome these limitations and are more applicable in real-world settings. The first such procedure is stratified sampling, which is used whenever we need to ensure that certain segments in the population are represented in the sample. It is always used in conjunction with simple or systematic random sampling. Schematically, it can be represented as shown in the diagram. The population is divided into segments or strata, with the strata being predefined by the researcher. Each segment or stratum consists of population members that share one or more characteristics. A simple random or systematic random sample is then drawn from each stratum and included in the final sample, as shown by the letter R. It is important, for reasons that will become clear shortly, that you notice the assumptions underlying the procedure. That is, population members are similar within a stratum because they share certain characteristics, but are different across strata. That is, each segment is systematically different from the others. Equally important, a sample is drawn from every stratum and no stratum is ignored. How the population is divided into strata would depend on the researcher's objectives. For example, if the objective was to determine interest in a new snack food, and the researcher expected that interest might vary by gender and age, then they might wish to segment based on those criteria and ensure that a sample was drawn from each of those segments. Note, however, that you also have to decide how many to draw from each stratum, and that's something we discuss next. Stratified sampling has several major advantages over the more elementary random sampling procedures we saw earlier. First, it ensures that all relevant segments are represented in the sample. Second, by dividing the population into more homogeneous strata and sampling directly from each, we are able to reduce the variability of each group that we sample from, and therefore we reduce the total sampling error, as noted in the previous module. We also have to decide how many sampling units to sample from each stratum. There are two possible approaches we can use. A proportionate stratified sampling procedure is when the percent of the sample from each stratum is the same as the percent of that stratum in the population. For example, if stratum 1 is 50% of the population, it would make up 50% of the sample under proportionate sampling. This is the default or typical scenario. A disproportionate sampling procedure is the case when we depart from proportionate sampling, that is, when the percent of a stratum in the sample is not the same as the percent of that stratum in the population. We might use this approach for a couple of reasons. First, we might want to do this when some of the segments are more important based on the research objectives, and therefore we need the results to be more accurate for those segments. To get more accurate results, we would increase the sample size for those segments, that is, oversample from or overrepresent the segment, so as to reduce the total sampling error and to get a more accurate readout for those segments. Assuming the total sample size from all the different segments is fixed, this would also mean that we would undersample from some of the other segments, that is, draw a smaller sample from them. A second situation when disproportionate sampling would be appropriate is when a segment is more heterogeneous, that is, it has more variability than other segments on the variables that we are measuring. Heterogeneity increases sampling error, as we saw earlier, so if we needed to reduce the sampling error for that segment, we would have to oversample from it. For example, if we are drawing a sample of supermarkets for a study to estimate sales of a product, we may want to oversample large supermarkets and undersample smaller ones for two reasons. Because larger stores are more important from the firm's perspective as they account for a larger percent of sales volume. And second, larger stores may also have higher variance in sales, so that would be an additional reason to oversample them. The second advanced sampling procedure is cluster sampling, also sometimes called area sampling. It too is always used in conjunction with simple or systematic random sampling. Schematically, it can be represented as shown in this diagram. The population is divided into clusters, which are not the same as segments. Clusters typically are formed based on naturally occurring groups of sampling units. For example, you could form clusters based on the physical locations or areas where sampling units can be found, in which case the sampling procedure is called area sampling. You could be quite creative in deciding how to form your clusters. For example, if you have a list of sampling units, that is a sampling frame that is several pages long, you could treat each page or part of a page as a cluster. Cluster sampling is based on the assumption that each cluster is a microcosm of the population. That is, it reflects the same heterogeneity as in the population. If this is true, each cluster will be similar in composition to the other clusters. Notice that clusters are not at all like strata. With strata, sampling units are similar within each stratum, but are different from those in other strata. With clusters, sampling units are different within a cluster, but each cluster resembles the others because they all reflect the same heterogeneity as the population. So now, when you draw the final sample in cluster sampling, you include some of the clusters but ignore the rest. This selection of clusters is done using simple random or systematic random sampling. As you can see in the diagram, a sample is drawn from clusters 1, 3, and k, as shown by the R's, but the other clusters are ignored. The reason you can do this is because, by assumption, each cluster is like the others, so it doesn't matter if you leave some of them out. Notice again that this is completely different from stratified sampling. In stratified sampling, you have to sample from every stratum, ignoring none. So even though the schematic diagram for cluster sampling looks very similar to stratified sampling, it is based on a completely different set of assumptions. Once you have selected the clusters to be sampled, you have a choice. You can include all the sampling units from each selected cluster, that is, take a census of the selected clusters. Or you can draw a sample from each selected cluster, in which case it is called two-stage cluster sampling or two-stage area sampling. This second stage of sampling also requires a simple random or systematic random sample. Why is cluster sampling used, or when is it useful? The main reason for using cluster sampling is that it is a very efficient way of sampling. In particular, if personal interviews are required and the population is geographically dispersed, that is, in different locations, cluster sampling can save significant time and cost in traveling to different locations to interview people. For example, if I have to interview 500 people who are located in 50 zip codes, it is more efficient to go to just 10 zip codes and interview 50 people at each than to go to 50 zip codes and interview 10 people at each. Even if geography is not involved, for example, if you're drawing a sample from a long list of population members, such as the phone book, it can save you time in physically selecting the sample. Cluster sampling is especially useful when a sampling frame or list of population members is not available. In this case, if you can find naturally occurring clusters in certain geographical areas, you can use that as a basis for cluster sampling. Now, the catch with cluster sampling is that it may be difficult to find or create clusters such that they are similar to each other as required by the procedure. But in that case, you can combine stratified and cluster sampling to arrive at a sample that is both representative, which is the objective of stratified sampling, and efficiently obtained, which is the goal of cluster sampling. Let's see how in the next slide. The basic idea of combining cluster and stratified sampling is that you can stratify the population and then form clusters within each stratum. This way you can get clusters within a stratum that are similar to other clusters, with each cluster mirroring the stratum that it is in. To take an example, supposing you wanted to sample people who shop at department stores in the city to measure their interest in purchasing a new product. You could treat each department store as a cluster since it is a naturally occurring grouping. You would prefer to only visit a few department stores to save time, but you know that all department stores are not alike in the characteristics of the people who shop there. So you should first stratify the stores based on the aspects that are relevant to your research objectives. For example, you might decide that the price level of the department stores is the most important basis for segmenting them. You would then divide the stores into 3 segments or strata: discount, mid-priced, and high-end, such that stores within a stratum are similar to each other. This is represented by the green rectangles in the diagram. So these are the strata. Then you would treat each store within each stratum as a cluster, and this is shown by the orange rectangles. you would randomly select one or more clusters to include in the final sample of stores. You will need to sample at least one store from each stratum to ensure that it is represented in the sample. In the diagram, stores 2, 4, and 8 are selected randomly, as shown by the set of R's on top of the stores. Finally, select a random sample of shoppers at the selected stores to include in the final sample. This is shown by the set of R's below the selected stores. In summary, in situations where cluster sampling is difficult to use because we cannot assume that all clusters are alike, we can use a hybrid approach that combines cluster and stratified sampling to get a representative sample that is also efficiently obtained.